Hello everyone. So one question I've been exploring throughout my Source of Truth newsletter is how do we design AI systems that don't just generate answers but rather generate answers that we can actually trust. So today I wanted to show you a practical proof of concept that brings those architectural idea to the life. I'll be using a legal document as an example. It could be any document, as easy could be your financial policy, your operating procedure, your audit report, or any sort of technical documentation or contract. Let's say the important point isn't just the document itself, it's how the architecture process it within different layers. So the journey begins here. As we uploaded and processed the data, it went through the Medallion architecture, and the first one is the bronze layer. Think of this as the system's point of ingestion. So at this stage, we are not just asking AI to understand anything, we are just simply extracting the raw content as faithfully as possible. So in this example, the document has been broken into four extracted segments, which roughly becomes 2000 characters. So the goal here is preservation. We are not summarizing, we are not interpreting, and we are just simply capturing the reality. So you can look through each segment here in this section here. And the second most important layer comes the silver one. So what I believe is this is one of the important stages because semantic chunking happens here. So AI models don't reason effectively over entire documents. Instead, we have to divide the content into smaller and meaningful knowledge segments. And how that happens in the background isn't just some random splitting by page or word count. It has to be designed in a way that each chunk is actually preserving the context as well, while making the retrieval far more precise. So as you can see, the document has been divided into 11 different chunks, and average character is about 700. Each one represents a focused area that the AI can later retrieve independently based upon the different uh, sections that the user is going to put in as a query. We'll be going to that part later on, but the third one here is the gold layer. So once the semantic chunking has been created, they move into this layer. This is where transformation becomes mathematical. Every chunk is converted into what's called an embedding. And embedding is simply a numerical representation of meaning in a vector format. So in this example, each chunk becomes a vector containing here, let's say 3000 dimensions. So rather than storing the words, the system can now store relationships between ideas. Similar concepts can become mathematically closer together, which allows retrieval based on meaning instead of exact keywords. So this is what modern RAG systems understand in terms of intent, rather than just matching the concept or matching the text using keyword-based searches. So now let's ask a question about this document. So noticed what just happened behind the scene. The language model isn't searching the entire document. First, the question itself is converted into an embedding, and that embedding is compared against all of the stored vectors. The architecture retrieves only the most relevant semantic chunks, and those trusted chunks becomes the context that the language model uses to generate its answer. So the response isn't coming purely from the model's memory. It is actually grounded in the uploaded document. And that is the key distinction between a standard chatbot and a retrieval augmented generation system. The architecture retrieves knowledge first and model reasons second. And one thing I would like to mention here and emphasize while building this proof of concept is that the language model is just one component of the system. The real work happens before generation ever begins. And bronze capture your information, silver organizes it, and gold is something that converts it into machine understandable representations. And retrieval happens and it finds the most relevant knowledge from embedded information, and only then does the language model generate its response. That is why I think trustworthy AI is fundamentally an architectural challenge. And this proof of concept brings together many of the ideas that I've explored throughout this Source of Truth series, from governance and Medallion architecture to embeddings, retrieval augmented generation system. So it is still a learning project, but it reinforces one idea that continues to stand out to me, which is that artificial intelligence doesn't become trustworthy because the model is larger. It rather becomes trustworthy because the architecture surrounding it is intentionally designed. So thanks for watching, and I'd love to hear your thoughts about it. And I'll be seeing you in the next issue of this series. Thank you.